Hello everyone. This video is going to show integration by parts. And so in this type of integration, we have to pick a u and a dv out of our original integral. The dv has to be a portion of the integral which is easily integrated compared to the original integral. So for this first problem, if I just write u and then dv in two columns, well, the antiderivative of e to the negative x dx is pretty easy to find. So I'm going to call the dv that portion, and then the u will be the leftover part, which is the x squared. There's also an acronym you can remember, LIPET, L-I-P-E-T, which helps you remember which order to pick the u in. Let's just write this out. L stands for log, I stands for inverse trig functions, like if you had sine inverse or cosine inverse. The P stands for any polynomial, like the x squared that's in our problem. The E stands for exponential, which would be like the e to the negative x. But since we had a polynomial, we picked that first. You pick the polynomial over an exponential. And then the T stands for trig function. So like a sine, cosine, tangent. That would be the last thing you would pick for u. So you pick them in the order of these letters. If there's a log in your problem, you would want that to be the u. Or if there's an inverse trig function in your problem, then you would have that be the u. So it's what takes precedence for picking the u. So now I'm going to go on the assumption that you guys have learned this and just need help doing the fine details here. So with u, we now take the derivative. So this is 2x. And then we're going to keep taking the derivative until we get to 0. So the derivative of 2x is 2, and then the derivative of 2 is 0. I wanted to show you a tabular problem where you can continue in the u column until you get 0. Now, with the dv column, I'm going to take the antiderivative. So the first antiderivative would be negative e to the negative x. The next antiderivative is back to positive e to the negative x. And the final antiderivative is negative e to the negative x again. Now the way that we compose the answer for this is we multiply in a diagonal method like this, and at the end you multiply the last row together. And there's also plus and minus signs that we have to be careful of. The first multiplication is plus, then it's minus, then it's plus, and then it'll finally be minus on this problem. So here's how we write the answer. We're going to take that times that. So we write down negative x squared e to the negative x. I just moved the negative in front because it should be part of the coefficient. And then this next diagonal is 2x times e to the negative x, but it has a minus sign as part of the formula, so it's going to be minus 2x e to the negative x. Then our third row down is that times that. That's back to a positive sign, but the e has a negative in front of it, so let's write negative in the very front, 2e to the negative x. And then our final row is this direction, but actually you can see that that's just going to be times 0. So what it really would be is minus the integral of 0 times negative e to the negative x dx. And then in a more straightforward problem, you would do that integral, and it would be an easier integral to do than the original problem. But this problem's actually even nicer, because since there's a 0 right here, this whole integral is just 0. So our final answer is going to be negative x squared e to the negative x minus 2x e to the negative x minus 2e to the negative x, and then it was an integral that we were doing, so we have to write plus c at the end because it was an indefinite integral. So now let's look at a second type of problem that you come across. I tried to pick the 2 harder types of problems to show, not just your typical example. So this one is considered a wraparound function. So if we go about picking our u and our dv, if I follow the whole idea of Lippitt, I don't see a logarithm, I don't see an inverse trig function, I don't see a polynomial. I do see an exponential, however, and that's followed by a trig function. So the exponential, e to the 2x, is going to be our u, and that leaves sine of 3x dx to be the dv. So now I take the derivative of the u column, so that's going to be 2e to the 2x, and I take the antiderivative of the dv column. Well, the first antiderivative of sine 3x is negative 1/3 cosine of 3x. Okay, now this integral in the last row would be no easier than the original integral, so I do the u column one more time. I take the derivative, which would be 4e to the 2x, and I take the antiderivative of the dv column one more time, so that's going to make it negative 1/9 sine of 3x. And I am going to stop here because here is what's going to happen. The original integral has e to the 2x sine of 3x in it. This last row, when I get to it, also has an e to the 2x sine of 3x in it. That's what is considered a wraparound, and there's a way of writing this now that won't be too difficult to figure out. So I'm going to get rid of the highlighting. And now we're going to work on composing our answer. So we know we multiply diagonally, and at the bottom we multiply across. And again, the pattern of plus and minuses always goes plus, minus, plus. Okay, so now I multiply my first diagonal together, all of that together. So I'm going to move the negative 1/3 into the front. So negative 1/3 e to the 2x cosine of 3x. Now I'll multiply the next diagonal, this times that. I'm going to move the 2 is in front and times negative 1/9 in front. So that, and on top of it, it's a minus. So let's just write it this way for right now. Minus negative 2/9 e to the 2x sine of 3x. Okay, and then I'm going to take my final row and multiply horizontally, and that row is my integral. That row is a plus sign, so I can do plus the integral, and the 4 times negative 1/9 I will put in the front, so negative 4/9 e to the 2x sine of 3x dx. So that is the integral that we need to evaluate. Now that integral is no easier than the original integral, but think about this. This is the answer to the original problem. So this is supposedly the answer to the original integral of e to the 2x sine of 3x dx. And if you notice, this integral has the e to the 2x and a sine of 3x in it. And look over at our integral on the right-hand side, it has those same two components to it. So what I'm going to do, think of this way. I'm going to erase the negative in front of the 4/9. Actually, I'm going to erase the 4/9. And I'm going to pull the negative 4/9 out in front of the integral sign, which is completely allowed. Then what I'm going to do, I just did that to make it look easier for you guys. We're going to add, just like regular algebra, we're going to add 4/9 e to the 2x sine of 3x dx. We're just adding that whole entire integral from this side, where it'll cross out, over to this side. Okay, now just add these. So this integral, if you think of common denominator, that's the same as having 9/9 of that original integral plus 4/9. So that gives me altogether 13/9 e to the 2x sine of 3x dx equals all this other stuff, negative 1/3 e to the 2x cosine of 3x, and then I'll change that to a plus 2/9 e to the 2x sine of 3x. And then we're trying to get a solution for this integral right here, because that's the same as the original problem, which is up here. And so now all I need to do is multiply both sides by 9/13, because that will isolate that integral. So if I just say, all right, all of this times 9/13, that's going to give us our final answer, because that's going to cross out. So I'm just going to clean this up a little bit. I moved my work over so I'd have more room. I'm just going to distribute the 9/13 to here, and at the very end I'm going to add c. So our final answer is saying basically the integral of e to the 2x sine of 3x dx, that's our original problem, equals negative 1/3 times 9/13. I'm distributing now. That gives us negative 3/13 e to the 2x cosine of 3x, and then plus 2/13. Try to squeeze this in. E to the 2x sine of 3x, and then plus c. This right here is the final answer. And so that's a wraparound. Anytime you're trying to get the same integral to pop up in the dv column, in the last row of our u dv setup, and it's the same as the original problem, that's a wraparound.